Alright, so let's investigate this question on Taylor series. We are given the function and we are asked to expand the given function as a Taylor series in x minus 1 and y plus 2 up to and including second order. So we are not to exceed the second order. Now, what's the Taylor series expansion in second order? The given function f(x) of y in Taylor series is simply equal to, first of all, you find the value of the function at the given point, x naught and y naught. Okay, so plus you find the partial derivative of the function first with respect to x at the given point x naught, y naught, then multiply by x minus x naught. Okay, plus also find the partial derivative of function with respect to y at the given point x naught, y naught, and also at multiply by y minus y naught. Okay, now you find 1 all over 2 factorial. In this case, now you find the second order derivatives, which includes the partial squared all over partial x squared at the given point x naught, y naught multiplied by x minus x naught all squared. Okay, plus partial squared f all over partial y squared at the given point x naught, y naught multiplied by y minus y naught, okay, all squared. And finally you find the mixed partial derivative partial squared f over partial x partial y also at the given points x naught, y naught, okay, multiplied in this case now by x minus x naught multiplied by y minus y naught. So this is the second order up to the second order partial derivative. So this series continues, okay, it continues like that even up to third, fourth, fifth order. Okay, so all we need to do now is simply find this given function and the given points. So we need to locate our points. We are given in x minus 1 and plus y plus 1. So let's get the points. Given points, okay, given points, we have x minus 1 and we have y plus 2. So let's relate this now to, okay, x naught, y naught. This is actually x minus x naught, okay, and this is supposed to be y minus y naught. So if you compare these two equations, it actually means that x naught, okay, is equal to 1. This minus and this minus, so x naught is equal to 1. And also, if you compare this other side, so if you compare this equation, it also means that y naught itself is actually equal to minus 2, because minus minus will actually give us plus. So y naught is actually minus 2. Okay, so let's start now. First thing, obtain the function at point x naught, y naught. So we are given this function, it becomes f of x naught, y naught, which is actually f of x naught is 1, f of 1, and y naught is minus 2 and minus 2. So wherever you see x in this equation, simply put as 1, and wherever you see y, put the value as minus 2. So in place of x, we simply have 1 multiplied by, next is y squared, and y is minus 2. So multiply by minus 2 all squared minus, we have here x squared, and x is 1, okay, minus 1 all squared. So this is actually equal to 1 times minus 2 squared remains plus 4 minus 1 squared here is 1. So this is actually 4 minus 1. So it simply means, first of all, f of x naught, y naught is actually equal to 3. Simply 4 minus 3. Keep this aside. So this part of the equation has been solved, of the series has been solved. Next is to find the partial derivative of that function with respect to x and find its value also at this point x naught, y naught. Okay, let's do that and see. So we are given that function f of xy to be equal to xy squared minus x squared. So we find the partial derivative of f only with respect to x. So which means we are going to treat y as a constant. If we do that, we'll keep simply here y squared as a constant, differentiate x. X is simply 1 minus differentiate x squared. I will simply have 2x. So which means partial f all over partial x is actually y squared minus 2x. So look for these values at the given points. The points become x naught, y naught now simply 1 and minus 2. So look for this value at 1 and minus 2. So this simply means that partial f over partial x at the given points 1 and minus 2 is equal to, in place of y squared here, y is minus 2, so I'll simply have minus 2 all squared minus 2 into x is 1 into 1. So this means partial f all over partial x at the given point 1 and minus 2 is now equal to, so this becomes 2 squared minus 2 squared is 4 minus 2 times 1 is 2, so the value is actually 2. Keep this aside. Next from the series is also what? Differentiate f with respect to y. Okay, so you outline the function and you differentiate with respect to y. Let's do that here. So partial f, okay, from the function f of xy is equal to x squared equals x y squared minus x squared. We differentiate this function with respect to y. That's simply equal to, so you hold x as a constant here, x is kept as constant, and you differentiate y squared. That simply gives you 2y. Okay, of course, if I differentiate x squared with respect to y, it becomes 0 because x squared is a constant. It doesn't contain any variable x. So it means this partial derivative is actually 2xy. So you find the value of this partial derivative at the given point, which is 1 and minus 2. This is now equal to, wherever you see x, put 1, and wherever you see y, put minus 2. So you simply have here 2 into x is 1, y is minus 2, and this is actually minus 4. So we'll have that part of the series solved. Partial f, partial y have been solved. Next is to find the double partial derivative of the function with respect to x and evaluate its value also at the given points. Let's do that and see. Okay, so we already have partial f all over partial x. We already obtained partial f over partial x over here, and the value is simply y squared minus 2x. We obtain that value as simply y squared minus 2x. So we simply differentiate this again with respect to x. That becomes partial squared f all over partial x squared, and that's equal to, if I differentiate y with respect to x, is completely 0 because there's no x variable attached to it. So y squared becomes a constant, it's gone. Now I differentiate x here, it gives me 1 multiplied by minus 2. That means this derivative is simply minus 2. So even at that point, partial squared f partial x squared still remains minus 2 because there's no x y variable attached to it, so it remains minus 2. You have this. Also, let's differentiate second partial derivative of the function with respect to y. We already obtained partial f partial y to be this 2xy. So from partial f all over partial y equals 2xy. We now differentiate again with respect to y. If you do that, you obtain partial squared f all over partial y squared, and that's equal to, so I will simply keep 2x as a constant, and if I differentiate y, y simply gives me 1, okay, times 1. So this is actually 2x. So find this value, partial squared f all over partial y squared at the given point, x is 1 and y is minus 2. So this is now equal to, wherever you see x, put in the value as 1. So I'll simply have here 2 into x is 1. So this actually remains 2. Alright, so the partial derivative of that function, the double partial derivative of that function with respect to y also gave us 2. Okay, so the final part of the equation is simply to find the mixed partial derivative, partial squared f, partial x, partial y at also those given points. That's the last thing to do. I think I can do that over here. Okay, so I have partial f, partial x to be this. Okay, next is simply partial squared f all over partial y, partial x. Simply differentiate this function with respect to y. I will simply obtain the value as 2y. So also take note, this can also be equal to partial squared f over partial x, partial y. You will still obtain the same thing. That's simply differentiating partial f, partial y with respect to x. With respect to x. So if I differentiate partial f partial y with respect to x, I will still obtain the value as 2y. So these two derivatives are the same. It doesn't change. It remains the same as 2y. Okay, so you find their values at the given point. The point remains 1 and minus 2. Let's obtain that. All right, okay. I think I will do that over here. So partial squared f all over partial x partial y at the given point 1 and minus 2 is now equal to, we said it's 2y, so this is actually 2 into y is minus 2 minus 2, and this is actually equal to minus 4. Okay, so we've gotten all the parameters we need for the series. We can now substitute into the series itself and write the functions. Okay, so the board looks a little bit tattered. So I'm going to wipe some portion and bring out all my variables for the series and keep it one side. I think we should do that here. Okay. All right. So first, I obtained um, fx naught y naught as 3. So simply fx naught y naught was given as 3. Next, I obtained partial f partial x at that point as simply 2. So let's put it down here. Partial f partial x at 1 and minus 2 to be equal to 2. Okay, next I obtain partial squared f partial x squared to be minus 2, partial squared f partial x squared at that point, my 1 and minus 2 to be equal to minus 2. Okay, next I obtain partial squared f partial y squared also at that point, 1 and minus 2 to be equal to 2. Next, I obtain the mixed partial derivative, partial squared f all over partial x partial y to be equal to minus 4. Okay, I think that's all. So we're simply going to plug this now into the given series and see what we have. Okay, also partial f over partial y at the given points 1 and minus 2 was also obtained here as minus 4. All right, so let's write the series now. I'm going to wipe here now. Okay, the series of that function, Taylor series of that function f of y is now equal to, we simply said f of x naught y naught, the function, the values of the function at the given points, it gave us 3. You put it down, 3 plus, next is partial derivative of f with respect to x at those points, multiplied by x minus x naught, and partial f partial x at that point gave us 2. So we simply have 2 times x minus x naught, which gave us x minus 1 here. So times x minus 1. Okay. Plus, next is partial f partial y at that point, multiply y minus y naught. And partial f partial y gave us minus 4. So that is simply going to say this becomes minus now. Okay, this becomes minus. So you have minus 4 multiplied by y. Okay, my y minus y naught simply give us y plus 2. Becomes y plus 2. Okay. Plus, next is, okay, the second order now, 1 all over 2 factorial. So you put it down, 1 all over 2 factorial multiplying by first partial squared f partial x squared at the given point multiply x minus x naught all squared. So partial squared f partial x squared give us minus 2. So you simply have minus 2 multiplied x minus x naught give us x minus 1 from the question, x minus 1 all squared, okay, plus next is partial squared f partial y squared, and partial squared f partial y squared give us 2. So we simply have plus 2 into y plus 2. Of course, y minus y naught was given in the equation as y plus 2. Okay, plus finally you obtain the mixed partial derivative, which is partial squared f partial x partial y, and we obtain that value simply as minus 4. So simply this becomes minus now. This becomes minus 4 multiplied by x minus x naught, which is x minus 1, multiply y minus y naught, which is y plus 2. So you have this. So the series continues. So let's rewrite. The Taylor series expansion of this function f of xy is now equal to 3 plus 2 into x minus 1 minus 4 into y plus 2. 1 all over 2 factorial remains 2. So now I can, okay, so plus 1 all over 2. 2 factorial remains 2. Okay, into minus 2 into x minus 1 all squared plus 2 into y plus 2 all squared, please, there is squared here, all squared, minus 4 into x minus 1 into y plus 2, and the series continues like that. Okay, so let's evaluate. We'll have this to be f of xy is equal to, this becomes 3 plus 2 into x minus 1 minus 4 into y plus 2. So I will expand the whole of this bracket with 1 over 2. It becomes minus 2 all over 2 into x minus 1 all squared, okay, plus 2 all over 2 into y plus 2 all squared minus 4 over 2 into x minus 1 into y plus 2. Okay, the series continues like that. Alright, so finally, the Taylor series expansion of that function is equal to, this is 3 plus 2 into x minus 1 minus 4 into y plus 2. From here, 2 divided by 2 is 1. So you simply have minus into x minus 1 all squared plus, same thing here, 2 divided by 2 is 1. You simply have y plus 2 all squared, okay, minus 4 goes into 2 here is 2. 2 into x minus 1 into y plus 2, and the series continues like that. So that is the Taylor series expansion of that given question. All right, so you have this. All right, guys, so I hope you find this video very interesting and helpful. Please, if you do, don't forget to share your thoughts in the comment section, and of course, if you have any question at all, you can hit me up on WhatsApp or state in the comment section, and I promise to respond to all your questions. I will see you in the next video. Thanks and cheers.